introductory lesson to calculus. So I went as far as this formula. Now, before I carry on, I just want to remind you that calculus is, or rather differential calculus is all about finding the gradients of functions. Okay? Calculus, or differential calculus rather, is all about finding the gradients of functions. That's what the topic is all about. Finding the gradients of functions. Okay? Now, you are going to find that the gradient has got different notations. Also, it has got different formulae besides the one that you know, which is this formula here. M equal to y2 minus y1 over x2 minus x1. Now, that formula for calculating gradient you were taught from grade 9. Okay? Now, this is for a straight line. Okay? When a function is not linear, then things change. Okay? So on Saturday, I derived this formula up to here. Please be aware that this formula here is for calculating the gradient of a function at any point. Okay? This formula can be used to determine the gradient of a function. I'm talking about a nonlinear function at any point. Okay? So, from this formula, we then need to introduce a new concept, which is called the definition of a derivative. Okay? So, the derivative from first principles. All right. So the way that I'm going to introduce this is, when you find gradient using this formula, that is m equal to the limit as h tends to 0 of f of x plus h minus f of x all over h, right? In calculus, instead of using m as our notation for gradient, we use a new notation which is mainly function notation. So, in differential calculus, m is replaced by f prime of x. Okay? Now, f prime of x is pronounced as, and when you say it, right, f prime of x is pronounced as I'm going to put as f prime of x. Okay? So when you pronounce this notation, it's function notation for gradient. Okay? In calculus, we don't denote the gradient by m. Okay? We denote the gradient by a new type of notation. But this is not the only one, though. I'll talk about the others. So in calculus, we don't represent the gradient by m. We represent it by this notation, which is function notation. F prime of x. Please, this is not a 1. Okay? It's not a 1. Right? F prime of x. So when you say it, okay, you say it as f prime of x. Or you can say the first derivative, right? I'm going to define what a derivative is. Okay, so m is replaced by f prime of x, right? Now, when that happens, okay, therefore, the formula above becomes, okay, that formula becomes f prime of x is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. Right? Now this formula here, it is one which is called the definition of a derivative from first principles. Okay, this formula is very important going forward. Okay, that formula is called the definition of a derivative from first principles. Okay. Yes.
I know that there's multiple different but in an example, is the one.
We use this one here. That's the one which you are supposed to use. Okay. The two are the same, but because of the notation used in calculus, differential calculus, we don't put m, we put f prime of x. Yes.
The f prime of x is an f and apostrophe.
Yes. It's f and an apostrophe here. But in maths, we just pronounce it as f prime of x. Okay. Okay. Right. Yes. Okay. I'm not going to talk about how I wrote, but it's not straight. Okay. Okay. All right. So f prime of x. F prime of x. Can you stop that and pay attention? F prime of x is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. Now, I want you to be aware that when you write this formula, okay, it is provided on the information sheet. But over the years, I have seen that learners write it incorrectly, but I'm going to emphasize that more as I go. Now, this limit part here, this limit here, pay attention. This limit part, it is never written on the left-hand side of the equal sign. Okay? It is always written before this fraction here. Okay? It is always written on the right-hand side next to that fraction. If it happens that you write it on the left-hand side, maybe by mistake or whatever, it means that you have written the formula incorrectly and you deserve a 0 if there is a mark for the formula. So this is how you are supposed to write it. Yes. You have to write this limit part. All right. So this formula here is called the definition of a derivative from first principles. So if you hear me saying determine the derivative from first principles, what I will be saying, use this formula to find the gradient. Okay? Right. Is that clear there? Right, let's move on to the next page. Now, the next page, I just want you to be aware of this. The gradient of a function at any point, okay, can be called right, number one, the derivative can be called the derivative of the function at that point. Okay? Please, I'm giving you alternative definitions of the gradient. Yes, ma'am?
So we haven't had your registration sheet, not for Saturday and not for today.
Okay, so sorry, ma'am. I'm not a registrar.
Okay?
Yeah,
That
so
is very strange. Sorry, this is what I've been told. We'll check again. Thank you.
so you're not a registrar, sir? Okay. Right, number two. You see, whoever told them made a mistake. I'm not a registrar. Okay, so the gradient of a function, okay, here we are talking about a nonlinear function, right? At any point is called the derivative of a function at that point. It is also called the rate of change. The rate of change of the function. Okay, at that point. Okay, it is also called the instantaneous rate of change of the function. Of the function at that point. Okay? Right, so the gradient, so if we are saying gradient, okay, I can also say the derivative, which is what I'm going to use the most. Okay, I'm going to use this word the most. Okay, but that's the most common. The instantaneous rate of change, instantaneous rate of change, rate of change. The infinite rate of change of it's a mistake. Listen. Don't behave like you don't make mistakes. The infinite rate of change of the function, right? Okay. Can I have your attention? So it is also called the instantaneous rate of change of the function at that point. All right. Is there anything else there? I think that's it. Okay. So can I have your attention, please? Allow me to just do some examples on how to use this formula here. Okay? How to use this formula. Now, based on your curriculum, you are only supposed to find the derivative. One, in most cases, to be of a quadratic function or a hyperbola. Okay? In rare cases, can you be asked to determine the gradient of a linear function? So you only have two functions that you're supposed to find the derivative of. Sometimes you can also have a case where you may be required to determine the derivative from first principles of a cubic function. So you're most likely to encounter three functions: quadratic, hyperbola, or cubic function. Now, the cubic function is a new function. You haven't been taught yet. Okay, that's what we'll do, I think, next week. Okay, so let's just do some examples. Right? With the examples, I'll start with a linear function. Okay, I'll start with a linear function. Okay? Let's say you have a linear function f of x equal to maybe 2x plus 1. All right? We want to find the derivative from first principle. So the question will be find the derivative from first principles. Okay? That will be the question. Okay, please be aware that we know that the gradient of this function f of x equal to 2x plus 1 is equal to what? By inspection, what's the gradient? It's a 2. Okay? Now, that's by inspection. If we want to use the definition of a derivative, if you want to use the definition of a derivative from first principles, it means that we have to use this formula. F prime of x is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. Okay? So, first thing, okay, since it's linear, it's a very straightforward function. I'm not going to determine f of x plus h separately, okay? But I'm just going to substitute. I hope you remember your function notation. So this f of x plus h here is going to replace that x, okay? Then where there is f of x here, we substitute f of x, okay? So your knowledge of function notation is extremely important, right? So this will become limit as h tends to 0 of, now I'm going to substitute x plus h where there is x there, so we get 2 times x plus h plus 1 minus, now since our function f of x is binomial, okay, I have to put that 2x plus 1 in brackets, so this will be 2x plus 1. Okay, this is all over h. Okay, by the way, before I carry on, I forgot to tell you this on Saturday. Uh, Calculus is a major topic, by the way. So when you write your maths paper 1, it contributes almost 35 to 40 marks of your paper 1. So that's like 20% will be calculus, right? So calculus and functions only, you can pass matric. I'm talking about getting just the minimum, calculus and functions, right? Those are the two major topics in maths paper 1. Your functions and graphs and differential calculus. They will contribute almost close to 50% of that paper, right? So here, I've substituted x plus h, where there is x there. It's just knowledge of function notation. Okay? Then I need to use my knowledge of algebra here. Whilst I'm doing that, I need to carry on writing limit as h tends to 0. Okay? If you stop writing that, then it means you are no longer using the definition of a derivative from first principles. So this will be the limit as h tends to 0 of 2x plus 2h plus 1 minus 2x minus 1. This is all over h. Okay? I hope you are following me. It's just algebra. Okay, now if you look at this expression, that is the numerator, this 2x and that minus 2x, they cancel out. This positive 1 and that minus 1, they will also cancel out. So our numerator is going to be 2h. Okay? All right? If I move on to the next page, can I get on? If I move on to the next page, we'll end up having the limit as h tends to 0 of 2h over h. Now, the good thing is that this h and that h will cancel out. Okay? Are you following that? Now, when you do that now, what happens is you end up having the limit as h tends to 0 of 2. Okay? Now, the limit of h tends to 0 of 2 is equivalent to 2 because the h is no longer part of the expression. So what this means is that f prime of x okay, it won't allow me to write f prime here, but let me see slowly. Okay, so what this means is the gradient that we get by inspection is equivalent to the gradient we get by using the definition of the derivative from first principles. Okay? So be aware that m is equivalent to f prime of x. They are both equal to what? To 2. Yes? That's what you missed on Saturday. Okay. But if there's anyone who has got an issue with this age, that was Saturday's lesson. So that you, when you are writing it, you know what you are writing, why you are putting that age there. I explained that on Saturday. Okay. All right. Can I?
You don't need to put a full stop at the end there. We have to put a full stop.
Where? Where?
There.
No.
You don't know, sir. If there's no full stop, no mark.
Okay, relax. don't over worry about things, please. All right. So I found the derivative from first principles, even though we knew the gradient or the derivative of the function by inspection. Right. So with the linear function, it's a little bit easier. Okay? It's a little bit easier. Any questions so far? Any questions? Right. Just to emphasize why I'm writing this. Please, I'm writing this so that you are aware that the gradient is the same as the derivative. Okay? Because most learners will finish metric without understanding the concept of this f prime of x. It's gradient.
So like in our answer, we would have to write.
No, you don't have to go as far as writing this. You just stop here. But as a teacher, I'm just emphasizing that the m that you're taught from grade 9, representing gradient, is equivalent to f prime of x. Is that clear to everyone? Right. So let's move on to a second example. So maybe we can call this one example 1. Right? You can call that one example 1. So let's call this one PG1. Okay? That's for the linear. All right, let's do quadratic. Okay? Let's do quadratic. The second example, right? By the way, today we have got another lesson in the afternoon. You know that? Yeah, so that's good news. It means that by the end of today, pay attention, please pay attention. By end of today, I would have covered all aspects on the definition of a derivative from first principles. Okay? Okay, I'm going to just give you a basic quadratic function. Okay, let's call it f of x equal to x squared minus 2. Okay? Well, the linear function is the simplest, okay, and is the easiest of the functions. When it comes to quadratic, it becomes a little bit more complex. So with this one here, can you pay attention? Pay attention. First thing, I'm going to determine f of x plus h. So f of x plus h, because it's going to be a long expression, f of x plus h will be equal to, I just have to substitute x plus h where there is x there. Here, I'll put x plus h there. So we'll end up having x plus h squared minus 2. Right? Then we need to simplify that expression. At this stage, I expect everybody to be aware that x plus h squared gives you a perfect square trinomial. So that perfect square trinomial will be x squared plus 2xh plus h squared minus 2. Yes?
Sorry. Can you basically why not it has eight and
Okay. All right. At least, thanks for asking. If you go back to the definition, that is, this is the definition of a derivative from first principles. All right? I'm sure you can see this term here in the numerator, that f x plus h. Right? If the function is linear, then it's very easy to find it. When it's quadratic, you get a long expression. So it is always better to find this f of x plus h separately. Then you substitute it later on after finding it. You understand what I'm saying? Okay, look here. Since this expression will be a long expression, okay, and it's not that easy to determine by inspection, like the linear. So you can determine it on the sideline or separately from the formula, right? Because we already know this. Okay, that's our original function. So to determine this one here, you can find it first separately from the formula. Then you can substitute after finding it. Are you following that? But if you think you are good at simplifying and so on, you can do it there. But you may make a silly mistake. Okay? And I'm saying this from experience. Okay, but if you can do it there in the formula, it's fine. Okay? But I would encourage you to determine it separately. Especially for the quadratic function and the quadratic, the hyperbola and the linear. You can get complex functions there. Or rather complex expressions. Okay, so that's the function, or rather this is the expression for f of x plus h. Then now I'm going to write my formula for the definition of a derivative from first principle. So f prime of x would equal to the limit as h tends to 0 of f of x plus h. I already know that. Okay, I now know that is the expression on top minus f of x all over h. I don't want anybody to end up hating me because you're going to force me to take action. Okay. Very soon. I'm serious. Everybody need to sit straight. Your body language is very important. I'm sure you can see my body language that I'm interested in what I'm doing. Yes, you can see. You don't need to be told. You can see that I'm interested in what I'm doing. All right. Okay. Let's get on. So this becomes the limit as h tends to 0 of. Now I'm going to substitute that expression. So that will be x squared plus 2xh plus h squared minus 2. Okay, that's f of x plus h only. Now it's better to put that in brackets, obviously, because the second expression is a binomial. So we'll put it in brackets, so we'll get x squared minus 2. This is all over h. Okay? All right? Now let's remove the brackets there. Okay? Then move on. So we get limit as h tends to 0 of x squared plus 2xh plus h squared minus 2 minus x squared. Okay, if I remove brackets there, I'll get minus x squared here. Then plus 2. But by the way, I know what the answer is going to be. Okay? I'll tell you later how I know. But I know the answer. All right? No, the answer is 2x. No, 2x. Okay, let's get on. So, let's cancel out this x squared and that minus x squared, they cancel out. The minus 2 and the plus 2, they cancel out. Then our numerator is going to be 2xh plus h squared. So this becomes limit as h tends to 0 of 2xh plus h squared all over h. Please, never ever substitute h equal to 0 at this point. Please, look at your numerator, factor out h. So if you factor out h, you get h times 2x plus h all over h. Okay? Right? Then you cancel out those two. Okay? Then this becomes the limit as h tends to 0 of 2x plus h. Okay? Now, when you get to a point where you want to substitute h equal to 0, that's when you stop writing the limit part. Okay? The moment you have not substituted the h equal to 0, you have to carry on writing this. Okay? I'm just reminding you because very soon you write the June examination. To me, the notation is important. You carry on writing this until you get to that point where you decide that you want to substitute h equal to 0. Then you stop writing it. Okay? So what this means is, at that specific point, okay, the gradient between 2 points on that function is going to be 2x plus h. At this stage, don't worry about what h is. Okay? But if h is equal to 0, it means we are now talking about a specific point. Remember what I said yesterday, sorry, on Saturday rather, that if you have your function, let's say, okay, it's quadratic, right, quadratic. If you have a point somewhere there, let's call this point here x1. Right? If you want to find the derivative using the concept of average gradient at a specific point, right? You need to choose a second point such that you know the x value there. So the second x value becomes x2. But that x2 is going to be equal to x1 plus h, right? So if the distance between x1 and x2 becomes 0, it means we are back to this point. Okay? So this h here, when it's 0, it means we are back to our original point, which is there. Okay? So here, I'm going to substitute now. Since I'm going to substitute, I don't need to write limit as h tends to 0. So the final answer will be 2x. So that will be our derivative. F prime of x will be equal to 2x. Okay? F prime of x will be equal to 2x. This step where you substitute h equal to 0, yes, you always have to show that. Right? It may not be given a mark, yes, but just show it. All right. By the way, a question like this, usually 5 marks. Okay? 5 marks. A question like this. And it always comes in examinations. Every metric paper, the first question on calculus is on the derivative from first principles. The first question. And it's 5, it will be 5 marks. Yes.
Could you just repeat the reason why we use calculus?
You are not here on Saturday, isn't it? This is the problem of not being there. Right? Of course, you might not have been there because of a good reason, but that's one of the reasons why I don't encourage learners to not attend. Right? Calculus has got 2 branches. Differential calculus, which is part of your curriculum. There's another branch which you don't do, which is called integral calculus. The differential calculus, can you stop talking? The differential calculus deals with the determination of gradients of functions using tangents or 2 curves. Or just to make it easy for you, differential calculus is all about finding gradients of functions. Yeah. That's what we'll be doing throughout. Finding the gradients of functions. Okay. Is there anybody who has got a question? Huh? Okay. Now, your class exercise. Your class exercise. Determine determine from first principles from first principles the derivative of okay. Can I have your attention? Since you are in metric, you've done algebra throughout your high school years, I'm going to ask you to determine the derivative of a hyperbola. So that will be, well, okay, let me just give you a simple one. 1 over x, f of x equal to 1 over x. Can you find that from first principles? Find the derivative of f of x equal to 1 over x. Yes, doing the same thing with the variable. That's first principle.
You know, when we doing finances,
Yes, yes. You're going to learn everything. Don't worry. For your June exam, there won't be any finance, but your trial exam, you are going to write finance. So we'll teach you grade 11 finance. It's not a very long topic. We'll just concentrate on the key things that you need to know. Then the stats is not a major topic as well, right? And the probability is not a major topic. So finance, statistics, and probability are not major topics. These are the main because we see all the that what? There is no stats in your June exam. I sent you the scope of testing almost 2 weeks ago. Okay, listen, before the bell rings, I need you to tell me what is the answer. Yes. It's all better to be for any other country. To do that, if you want to find the derivative from first principle, complicate things. Just don't complicate it. That is the same as x plus h to the power of minus 1 is the same as 1 over x plus h. Work with it like this. It's your book, you're supposed to use the pen. Find f of x plus x will replace this x here by x plus x. And then you substitute it into the formula. Are you aware that this function expression becomes 1 over becomes 1 divided by x plus h. Yes, don't complicate things. This is your one. What I should like in practice. You do it like this and you complicate things. Okay? All you have to do is write this f plus h is equal to, where there is x here, put what? X plus h becomes 1 over x. Then substitute this here. And then put that 1 over x here. Don't try to introduce exponent. Please, listen, just to emphasize, don't introduce exponents. Okay? Don't introduce exponents. Otherwise, you won't be able to find that derivative. If you found the level of x plus h, I think it's x plus this 1 over x plus h. Minus then you was to construct position. Okay, can I have your attention? Can I have your attention? I can see that you forgot some key things, but it's very surprising though. Okay, can I just